Welcome to Hired in IT. Our mission is simple: help you build the skills that employers actually want. Whether you're trying to land your first IT job, switch careers, earn a promotion, or increase your salary, we're here to help. Every video is thoroughly researched and designed to make complex IT topics easy to understand. If there's an IT topic you'd like us to cover, leave a comment below. We may turn your suggestion into our next video. Turning IT knowledge into career opportunities. AI skills are becoming valuable across more than just traditional AI jobs. Research cited in this video shows that job postings requiring AI skills can command a meaningful salary premium compared with similar roles that don't require those capabilities. But here's the important part. You don't necessarily have to throw away your existing IT experience and start over. Cloud engineers can add AI deployment skills. Developers can learn LLM integration. Data professionals can build AI-ready pipelines. DevOps engineers can move toward MLOps and AI platforms. And architects can learn how to design secure enterprise AI systems. So the question isn't simply, how do I get an AI job? A better question is, which AI skills create the best bridge from the IT experience I already have? That's what we're going to figure out. Let's clarify what an AI salary premium actually means. If labor market data shows that jobs requiring AI skills earn more on average, that does not mean adding one AI skill automatically increases your personal salary by the same percentage. Compensation depends on experience, location, industry, employer, responsibilities, and the scarcity of your overall skill set. The useful signal is this: employers are increasingly attaching economic value to workers who can combine their existing domain expertise with AI capabilities. A cloud engineer who understands AI infrastructure. A developer who can integrate language models. A security professional who understands AI risk. A data engineer who can build pipelines for AI systems. That's the opportunity. Not replacing your existing skills, stacking AI on top of them. AI hiring isn't limited to research labs anymore. Organizations need people who can build AI applications, prepare data, deploy models, operate AI infrastructure, secure AI systems, and integrate AI into existing business applications. That means AI demand increasingly touches traditional IT disciplines: cloud, software development, data engineering, DevOps, cybersecurity, architecture, and product management. The important career signal isn't that every IT job is becoming an AI job. It's that AI capability is becoming another valuable technical layer across many existing roles. And that creates multiple entry points depending on what you already know. Here's the opportunity I want you to focus on. Companies don't just need people who understand AI theory. They need people who can make AI work inside real organizations. Someone has to connect the model to enterprise data. Someone has to deploy it. Someone has to secure it. Someone has to monitor it. Someone has to control access. Someone has to build the APIs and pipelines around it. And someone has to explain the architecture to the business. That's why existing IT experience can be extremely valuable. The gap isn't simply, we need more AI researchers. It's also, we need more IT professionals who understand how AI fits into production systems. Let's clear up 4 myths before we look at the jobs. Myth 1. You need a PhD. For research-heavy positions, advanced academic training can absolutely matter. But many applied AI roles focus on engineering, integration, data, deployment, operations, architecture, or product delivery. Myth 2. You have to become a software engineer first. Programming helps, especially Python. But your existing specialization still matters. Cloud, security, networking, databases, DevOps, and architecture can all become foundations for AI-focused roles. Myth 3. AI will simply replace IT. The reality is more complicated. AI will automate some tasks, change others, and create demand for new technical capabilities. Your goal is to move toward the work where AI increases the value of your expertise rather than competing with repetitive tasks you already perform. And myth 4, it's too late. AI technology is still changing rapidly. You don't need to know everything. You need to start building useful skills now. When a company ships a production AI system, it usually takes more than one type of professional. Data engineers build and maintain the pipelines that provide reliable data. ML engineers work closer to the model lifecycle, training, evaluation, optimization, inference, and deployment. AI engineers build applications and systems around AI models. ML ops and AI platform engineers create the infrastructure that lets teams deploy, monitor, and operate AI reliably. AI solutions. Architects design how models, data, applications, security, and cloud services fit together. And AI product managers connect those capabilities to an actual business problem. That's the opportunity for IT professionals. You don't have to become an AI researcher. You can find the part of the AI production stack that best matches the skills you already have. Instead of asking which AI job pays the most, start with a better question. Which AI role gives me the most leverage from what I already know? If you're a developer, AI engineering may be the natural path. If you work with databases, ETL, or analytics, data engineering is a strong bridge. If you're in DevOps, Kubernetes, or cloud operations, look closely at MLOps and AI platform engineering. If you're already designing cloud and enterprise systems, AI solutions architecture may be one of your strongest paths. If your strengths are business requirements, stakeholders, and product delivery, AI product management may fit better. And if you want to work deeper in model development, evaluation, and optimization, ML engineering may be your destination. Don't start over unless you have to. Build from your strongest existing foundation. AI engineering can command strong compensation, particularly for experienced engineers who can build production AI systems. You'll see salary ranges vary significantly across surveys and job postings. That's because AI engineer can describe very different jobs. One company may want an application developer integrating LLM APIs. Another may expect RAG, agents, cloud infrastructure, model evaluation, and Kubernetes. And senior engineers may be responsible for architecture and technical leadership. So don't memorize one salary number. Look at the responsibilities. The more production problems you can solve, integration, retrieval, evaluation, deployment, security, reliability, the more valuable your overall skill stack becomes. So what does an AI engineer actually do? At the simplest level, an AI engineer builds production applications and systems that use AI models. That might mean integrating a language model through an API, building a RAG system that retrieves company knowledge, giving an AI agent controlled access to business tools, connecting models to databases and applications, building evaluation pipelines, adding guardrails, monitoring quality, latency, and cost, packaging applications with containers, and deploying them into cloud environments. Some AI engineers work heavily with LLMs. Others work with traditional machine learning models. The important distinction is that you're not just experimenting with a model, you're engineering a reliable system around it. You don't need to learn every AI tool at once. Start with the foundation. Python. Learn enough to manipulate data, call APIs, handle JSON, and build simple applications. Next, understand REST APIs and model SDKs. Then learn the fundamentals of embeddings, vector search, RAG, tool calling, structured outputs, and model evaluation. After that, add production skills, Git, Docker, cloud deployment, authentication, logging, monitoring, and eventually orchestration technologies such as Kubernetes when your environment actually requires them. Frameworks such as LangChain or similar tools can help you build AI applications, but don't confuse learning a framework with learning AI engineering. Frameworks change. The architecture underneath them matters more. Here's a practical path from traditional IT into AI engineering. Step 1. Learn enough Python to build useful applications. Focus on APIs, JSON, files, error handling, and basic data manipulation. Step 2. Use a managed AI service or model API to build something small. Send input. Receive a model response. Then integrate that capability into an application. Step 3. Build a portfolio project that solves a real problem. A RAG assistant for technical documentation is a great example. Add authentication, citations, evaluation, logging, and a simple user interface. Now you're demonstrating more than prompting. You're demonstrating engineering. And step 4. Deploy it. Put the application into a cloud environment and document the architecture. A working system that you can explain is much stronger evidence of your skills than a resume containing 20 AI buzzwords. You'll see stories about AI professionals earning extremely high compensation. But there isn't one secret skill that automatically gets you there. Top compensation usually reflects a combination of factors: deep technical ability, experience, system design, business impact, specialized expertise, leadership, and the ability to solve expensive problems reliably. Fine-tuning can be one valuable specialization. So can RAG, agents, evaluation, inference optimization, AI security, ML ops, or distributed AI infrastructure. The lesson isn't, learn LoRa and make $300,000. The lesson is, build a rare combination of skills that lets you solve important production problems. That's where career leverage comes from. AI engineer and ML engineer overlap, but their center of gravity is different. AI engineers generally work closer to the application and system layer. They're thinking about APIs, RAG, agents, integrations, evaluation, security, deployment, and the user experience around AI. ML engineers generally work closer to the model lifecycle. They're more likely to focus on training pipelines, feature engineering, model evaluation, optimization, inference performance, and production model operations. That doesn't mean every ML engineer designs new neural networks. And it doesn't mean AI engineers never work directly with models. There's plenty of overlap. For many traditional IT professionals, AI engineering can provide a more direct entry point because cloud, APIs, containers, security, and integration skills transfer naturally. ML engineering can also command strong compensation, but the role typically expects deeper knowledge of machine learning. You'll need to understand more than how to call a model API. Think training and validation, feature engineering, model evaluation, experiment tracking, inference, data quality, and the statistics behind determining whether a model actually works. As you move deeper into model development, stronger foundations in probability, statistics, linear algebra, and optimization become increasingly useful. So, if you love the model itself, not just the application around it, ML engineering may be the path worth exploring. If ML engineering is your target, your toolkit goes deeper into the model lifecycle. Python is still the foundation. For traditional machine learning, libraries such as scikit-learn help you build, train, and evaluate models. For deep learning, frameworks such as PyTorch are widely used for neural networks, training workflows, and model experimentation. You'll also need strong data skills. NumPy and Pandas help you manipulate and prepare data, while SQL remains important because production models depend on reliable data sources. Then comes experiment management. You need a way to track model versions, parameters, metrics, datasets, and results so you can reproduce what worked and understand what didn't. As you move toward production, add Git for version control, Docker for packaging, cloud platforms for compute and deployment, model registries, monitoring, and orchestration or MLOps platforms when the scale of your environment requires them. But remember, knowing the tools isn't enough. An ML engineer needs to understand the complete life cycle. Prepare the data, train the model, evaluate it, deploy it, monitor it, and improve it when performance changes. That's the engineering part of machine learning engineering. Every AI system depends on data. Documents, transactions, logs, images, events, customer records, sensor data. Whatever the source, somebody has to ingest it, clean it, transform it, govern it, and make it available reliably. That's why data engineering remains one of the strongest bridges into AI. If you already work with SQL databases, ETL, cloud storage, or data integration, you have a useful foundation. Then you can add Python, data orchestration, distributed processing, cloud data platforms, streaming, data quality, and AI-specific pipelines. Models will continue to change. Reliable data engineering will remain essential underneath them. Data engineering can provide strong compensation and a durable career path because AI doesn't eliminate the need for reliable data. It increases it. The exact salary varies by experience, geography, industry, employer, and technology stack. But focus less on memorizing a salary range and more on the business value of the role. If an organization's data pipelines fail, its dashboards fail, its analytics fail, its machine learning pipelines fail, and increasingly, its AI applications fail. That's why engineers who can make data reliable remain valuable even as the models above that data change. If you're targeting data engineering, start with SQL. Learn joins, CTEs, window functions, data modeling, and query optimization. Then add Python for automation and data processing. From there, learn an orchestration platform and a distributed processing technology such as Spark. You'll also need experience with modern cloud data platforms and storage. The exact vendor matters less than understanding the architecture. How does data enter the system? Where is it stored? How is it transformed? How do you monitor failures? How do you maintain quality? And how do downstream analytics and AI systems consume it? If you already work with databases or ETL, you're not halfway finished. But you do have a foundation worth building on. Here's a practical 4-step data engineering path. First, become strong in SQL, especially joins, CTEs, window functions, aggregation, and query troubleshooting. Second, add Python and learn how to transform data programmatically. Third, build a cloud data pipeline. Pull data from a public API, store the raw data, clean and transform it. Schedule the workflow. Handle failures. Then load the result into an analytics-ready destination. And fourth, document the architecture. Show the source, ingestion, storage, transformation, orchestration, monitoring, and final output. That portfolio project demonstrates much more than passing a certification exam. It shows that you understand how data moves through a real system. AI product management can offer strong compensation, particularly for experienced product leaders working on high-impact AI products. But just like AI engineering and data engineering, there isn't one salary number you should memorize. Compensation varies significantly by location, company, experience, product responsibility, and whether you're looking at base salary or total compensation. At some technology companies, equity and performance incentives can make total compensation substantially higher than base salary alone. The more useful career question is, why would an organization pay a premium for an AI product manager? Because this role sits between 3 difficult problems. What can the technology actually do? What does the user actually need? And how can the company turn that capability into measurable business value? You don't necessarily need to be the person training the model, but you need enough AI knowledge to make good decisions about the product built around it. So what does an effective AI product manager actually need to know? First, AI fundamentals. You should understand what modern AI systems can and cannot reliably do. That includes concepts such as hallucinations, RAG, agents, evaluation, latency, model cost, context limits, privacy, and guardrails. Second, product discovery. AI doesn't make a bad product idea good. You still need to understand the user, identify the problem, test assumptions, and determine whether AI actually improves the solution. Third, evaluation. Traditional software often behaves predictably. AI doesn't. You need to define what a good response looks like, identify failure modes, establish quality metrics, and work with engineering teams to evaluate model behavior. Fourth, experimentation. That can include A/B testing, prototype testing, prompt experiments, model comparisons, and measuring whether the AI feature actually improves the user experience. Fifth, risk management. You need to think about privacy, security, bias, hallucinations, inappropriate outputs, regulatory requirements, and what happens when the AI is wrong. And sixth, communication. You're translating between users, executives, designers, data teams, and engineers. You don't need to write the production code, but you absolutely need to understand the trade-offs well enough to ask the right questions. That's what separates an AI product manager from someone who simply adds AI to a product roadmap. If AI product management is your target, focus on demonstrating product thinking around AI. First, learn enough AI fundamentals to understand what models can and cannot reliably do. You should understand concepts such as hallucinations, evaluation, RAG, model cost, latency, privacy, and guardrails. Second, perform an AI product teardown. Choose an existing AI feature and analyze. What user problem does it solve? Why does AI improve the experience? Where can it fail? How would you measure success? Third, create your own AI product proposal. Write a short PRD containing the user problem, requirements, success metrics, risks, evaluation strategy, and rollout plan. And fourth, build or prototype something. You don't have to become a production software engineer, but being able to demonstrate the user experience and explain the AI trade-offs will make your product thinking much more credible. Let's come back to that AI salary premium. There's an important mistake I don't want you to make. If labor market data shows a 28% premium for jobs requiring AI skills, that doesn't mean you can take your current salary, multiply it by 1.28, and predict what you'll earn after learning AI. That's not how labor market statistics work. Different jobs have different responsibilities, experience requirements, industries, locations, and talent pools. Instead, treat the premium as a market signal. Organizations are placing additional value on people who can combine domain expertise with AI capability. So don't ask, how do I add 28% to my salary? Ask, what valuable problems can I solve when I combine AI with the IT skills I already have? That's the career strategy. You don't need an expensive bootcamp to start. Here's a practical low-cost path. First, learn Python fundamentals using a reputable free or low-cost course. Second, build a simple application using a current model API or managed AI platform. Third, move beyond a basic chatbot. Add retrieval, structured outputs, tool calling, evaluation, or another capability that demonstrates real engineering. Fourth, publish the project with documentation explaining the problem, architecture, security considerations, limitations, and what you learned. And if a certification aligns with the cloud platform you're already using, consider adding it afterward. The order matters. Learn, build, deploy, document. Then certify where it strengthens the story. Certifications can help validate structured learning, but they shouldn't become your entire AI career strategy. Instead of chasing every certification, choose one that supports the role and technology environment you're targeting. If you're working in AWS, evaluate AWS's current AI and machine learning certification paths. If you're targeting Google Cloud, look at Google's current machine learning and generative AI credentials. And if you're working in Microsoft environments, evaluate the current Azure AI certification path. Data-focused professionals may also benefit from credentials aligned with the cloud data platforms they actually use. But remember, certification programs change. Exams are updated, some retire, new ones appear. So always verify the current certification requirements directly with the vendor before beginning your study plan. And don't confuse certification with capability. A certification can validate knowledge. A portfolio demonstrates what you can build. Real experience demonstrates what you can operate. The strongest career story combines those things strategically. Here's an AI career path. Traditional IT professionals should pay close attention to MLOps and AI platform engineering. These engineers build and operate the infrastructure that AI teams depend on. Think cloud platforms, containers, Kubernetes, CI/CD, infrastructure as code, model deployment, inference endpoints, monitoring, secrets management, identity and access control, GPU infrastructure, cost management, and observability. Their job is to help data scientists and AI engineers move models and AI applications from experimentation into reliable production environments. If you're already a DevOps engineer, cloud engineer, systems engineer, SRE, or platform engineer, many of these skills should sound familiar. That's the advantage. You're not throwing away your infrastructure experience. You're applying it to a new workload. Instead of only deploying web applications, you're also deploying models and inference services. Instead of only monitoring CPU and memory, you may also monitor model latency, GPU utilization, inference errors, quality signals, and cost. Instead of only building application pipelines, you're supporting model and AI application lifecycles. For infrastructure professionals, this can be one of the most natural bridges into AI. So what should you learn for MLOps, or AI platform engineering? Start with the infrastructure skills many IT professionals already know: Linux, networking, cloud platforms, Git, containers, CI/CD, infrastructure as code, monitoring, and security. Then add the AI-specific layer. Learn how models are packaged and deployed. Understand inference endpoints. Learn model registries and experiment tracking. Understand GPU workloads and why AI compute behaves differently from ordinary application servers. Learn how teams version models, data, configurations, and application code. Understand model monitoring and how AI workloads introduce additional concerns around quality, latency, drift, reliability, and cost. Then learn the platforms your target employers actually use. That might include Kubernetes, managed machine learning platforms, MLflow, cloud AI services, or other MLOps tooling. The key isn't memorizing every product. It's understanding how to build a repeatable path from experiment to deployment to monitoring to reliable production operations. If you already design cloud or enterprise systems, don't overlook AI solutions architecture. An AI solutions architect connects the entire system. Which model should we use? Where should it run? How does it securely access enterprise data? Do we need RAG, vector search, a knowledge graph? Agents? How do identity and permissions work? How do we protect sensitive information? How do we integrate with existing applications and APIs? How do we evaluate the AI? How do we monitor quality, latency, reliability, and cost? And what happens when the model fails? This role combines AI knowledge with architecture, cloud, networking, identity, security, data, governance, integration, and business requirements. That's why experienced IT professionals can have an advantage. You already understand much of the enterprise environment. Now you're adding the AI architecture layer. You're not just asking, which model should we use? You're asking, how do we turn this model into a secure, reliable, supportable enterprise solution? Let's make sure the roles are clear. If you're building AI-powered applications and integrations, think AI engineer. If you're working deeper in training, evaluation, optimization, and the model lifecycle, think ML engineer. If you're building reliable pipelines and data foundations, think data engineer. If you're building the infrastructure that deploys and operates AI systems, think MLOps or AI platform engineer. If you're designing the complete enterprise solution across models, data, security, cloud, and governance, think AI solutions. Architect. And if you're deciding what AI products should be built and how success should be measured, think AI product manager. Different roles, different centers of gravity, but all 6 contribute to the same production AI ecosystem. Here's the one decision framework I want you to save. Start with the kind of work you enjoy most. Do you like building applications, working with APIs, and turning ideas into working software? Choose AI engineer. Do you want to work deeper with models, training, evaluation, optimization, and inference? Choose ML engineer. Do you enjoy SQL, ETL, databases, pipelines, and making data reliable? Choose data engineer. Do you enjoy cloud infrastructure, containers, automation, CI/CD, monitoring, and keeping production systems running? Choose MLOps or AI platform engineer. Do you enjoy designing complete enterprise systems and making decisions across cloud, security, identity, data, applications, and governance? Choose AI solutions. Architect. Do you enjoy users, requirements, business strategy, metrics, experimentation, and deciding what should actually be built? Choose AI product manager. Here's the shortcut. Build the AI application. AI engineer. Build or optimize the model. ML engineer build the data foundation. Data engineer build the AI platform. MLOps, AI platform. Engineer design the whole solution. AI solutions. Architect decide what AI product to build. AI product manager. Don't choose based only on salary. Choose the role that best matches the type of work you want to do and the strengths you already bring. Do you need advanced mathematics to work in AI? It depends on the role. If you're building applications using existing language models and APIs, you can start without advanced mathematics. You should still understand basic statistics, probability, model evaluation, and how to interpret metrics. For data engineering, MLOps, AI platform engineering, and AI solutions architecture, strong systems knowledge may matter much more initially than advanced mathematics. But as you move toward ML engineering, model development, optimization, or research, the mathematical requirements increase. Statistics becomes more important. Probability becomes more important. Linear algebra becomes more important. And optimization becomes more important. So don't let advanced math stop you from starting in applied AI. But don't pretend mathematics doesn't matter either. Match the depth of mathematics you learn to the AI career you're actually pursuing. Here's your next action. Choose one target role, not 5. 1. Then open 10 real job descriptions for that role. Write down the skills that keep appearing. Now compare that list with what you already know. That gives you your real skills gap. Pick one missing skill. Learn it. Build something with it. Document what you built. Then move to the next gap. Maybe your first step is Python. Maybe it's RAG, Docker, SQL, data pipelines, model evaluation, cloud AI, MLOps, or system design. The specific skill will be different for everyone. The process stays the same. Choose the role. Study real job requirements, find the gap, build the skill, create evidence. Repeat. That's how you turn AI career planning into an actual transition strategy instead of another list of buzzwords. Remember, careers aren't built by watching videos. They're built by applying what you learn. So don't leave this video with 6 possible careers floating around in your head. Pick one. Find the skills employers repeatedly ask for. Build one project that proves you can use those skills. Then explain what you built, why you made those architecture choices, what failed, and what you improved. That's how you turn learning into evidence. And evidence is what helps you compete for the job. Thanks for watching Hired in IT, where we're turning IT knowledge into career opportunities.